NASA's InSight lander recorded a magnitude 4 Marsquake last December, but scientists learned only later the cause of that quake, a meteorite strike estimated to be one of the biggest seen on Mars since NASA began exploring the cosmos. What's more, the meteorite excavated boulder-sized chunks of ice buried closer to the Martian equator than ever found before, a discovery with implications for NASA's future plans to send astronauts to the Red Planet. Scientists determined the quake resulted from a meteorite impact when they looked at before and after images from NASA's Mars Reconnaissance Orbiter (MRO) and spotted a new, yawning crater. Offering a rare opportunity to see how a large impact shook the ground on Mars, the event and its effects are detailed in 2 papers published in the journal Science. The meteoroid is estimated to have spanned 16 to 39 feet, 5 to 12 meters, small enough that it would have burned up in Earth's atmosphere, but not in Mars' thin atmosphere, which is just 1% as dense as our planet's. The impact, in a region called Amazonas Planitia, blasted a crater roughly 492 feet across and 70 feet deep. Some of the ejecta thrown by the impact flew as far as 23 miles away. With images and seismic data documenting the event, this is believed to be one of the largest craters ever witnessed forming any place in the solar system. Many larger craters exist on the Red Planet, but they are significantly older and predate any Mars mission. It's unprecedented to find a fresh impact of this size, said Ingrid Dauber of Brown University, who leads InSight's Impact Science Working Group. It's an exciting moment in geologic history, and we got to witness it. InSight has seen its power drastically decline in recent months due to dust settling on its solar panels.
About a month ago, we got an additional challenge to the spacecraft. If I could have the next image. This is a global mosaic of Mars. It was taken over the course of a day, and it shows a large dust storm in the southern hemisphere that started kicking up about a month ago. If you go to the next image, we can see the dust storm shown in the orange, so you can see where it is. Fortunately, that dust storm did not move over InSight itself. InSight is over on the right side of this image, one of those spots on the right side of the image. And so that was really fortunate, because if it had passed over the spacecraft, it would have darkened the solar panels and we probably would have lost the spacecraft.
The spacecraft now is expected to shut down within the next 6 weeks, bringing the mission's science to an end. InSight is studying the planet's crust, mantle, and core. Seismic waves are key to the mission and have revealed the size, depth, and composition of Mars' inner layers. Since landing in November 2018, InSight has detected 1,318 Marsquakes, including several caused by smaller meteoroid impacts. But the quake resulting from last December's impact was the first observed to have surface waves, a kind of seismic wave that ripples along the top of a planet's crust. The second of the 2 science papers related to the big impact describes how scientists use these waves to study the structure of Mars' crust. In late 2021, InSight scientists reported to the rest of the team they had detected a major Marsquake on December. The crater was first spotted on February by scientists working at Malin Space Science Systems, MSSS, which built and operates 2 cameras aboard MRO. The context camera, CTX, provides black and white, medium-resolution images, while the Mars Color Imager, MARSI, produces daily maps of the entire planet, allowing scientists to track large-scale weather changes like the recent regional dust storm that further diminished InSight's solar power. The impact's blast zone was visible in MARSI data that allowed the team to pin down a 24-hour period within which the impact occurred. Establishing the rate at which craters appear on Mars is critical for refining the planet's geologic timeline. On older surfaces, such as those of Mars and our Moon, there are more craters than on Earth. On our planet, the processes of erosion and plate tectonics erase older features from the surface. New craters also expose materials below the surface. In this case, large chunks of ice scattered by the impact were viewed by MRO's high-resolution imaging science experiment, HiRISE, color camera. Subsurface ice will be a vital resource for astronauts, who could use it for a variety of needs, including drinking water, agriculture, and rocket propellant. Buried ice has never been spotted this close to the Martian equator, which, as the warmest part of Mars, is an appealing location for astronauts. We are excited to see a man on Mars. Till then, stay tuned and stay curious.